The SaaS Analytics Dashboard presents a sleek, modern, web-inspired interface that is built entirely for native mobile environments. But this interface was built entirely without standard native XML layout tools. It relies instead on B4X, a rapid prototyping framework. Specifically, the codebase utilizes B4XDaisy UI Kit, a declarative UI wrapper inspired by Tailwind CSS. This raises an architectural question. How does this toolset take web-based UI concepts and translate them into performant native mobile views under the hood? The structure relies on two core pillars. The first is programmatic view assembly, where layout boundaries are driven by real-time mathematical resizing. The second is a strictly centralized router that handles all application state and global overlays. Analyzing this codebase shows how bypassing XML layout bloat remains compatible with native device performance and memory safety. In a traditional Android environment, developers define UI components within static XML files. Here, components are initialized purely through code. The responsiveness of the entire application hinges on a single event hook, B4XPage resize. The top navbar initializes, locked to a static height of 56 pixels. A bottom dock anchors to the base with a height of 64 pixels. The framework dynamically calculates the remaining scrollable area by subtracting both from the total screen height. To enforce these exact dimensions, the engine calls the setLayoutAnimated method, drawing the mathematical boundaries directly onto the screen during rendering. Because these boundaries are evaluated at runtime, the layout avoids the rigid constraints that complicate traditional XML view hierarchies. Whenever the device environment changes, whether through a screen rotation or entering split screen mode, the B4XPage resize event fires, recalculating the available pixels for every component. Treating view boundaries as mathematical functions rather than static markup guarantees exact pixel responsiveness across any display dimension. Behind these dynamic views is a routing architecture, determining how the dynamically constructed pages move and interact. A common structural flaw in mobile development occurs when individual child pages manage their own navigation. This creates fragmented logic and unmanaged navigation stacks. This codebase establishes B4X main page as the absolute central router. When a user taps Settings, the child page simply routes the request up to the central hub. The hub displays a transition icon, then commands the framework to reveal the Settings page. During this transition process, the underlying framework updates an internal array called mStack of page IDs to track the user's explicit path. When a user navigates backward, a different sequence executes to clear memory. The active page triggers the close page with loader subroutine, passing itself as an argument back to the central router. The router explicitly closes the view, popping its ID off the navigation stack array. This prevents the stack from accumulating hidden pages in the background over long sessions. Delegating all stack management to a singleton controller isolates page logic. The individual screens remain functional, stateless, and highly reusable. This centralized approach also extends to UI elements existing outside the standard page flow, specifically floating suite alerts and canvas spinners. If an alert attaches to a specific child page's view hierarchy, it will glitch or vanish if a transition executes while it's visible. The show_swal_alert method resolves this by scanning the z-axis depth, attempting to attach the alert to the highest active root layer. If that top page is unavailable, fallback logic attaches the alert to the overarching global parent layer, situated above the entire page stack. To prevent overlapping dialogues, the framework utilizes an active alert tracker. It identifies older toasts, strips them from the view, and draws the new ones. Centralizing the overlay management prevents z-index collisions and orphaned elements, ensuring critical user feedback is always visible regardless of the current routing state. High-level rapid application abstractions often hit a strict roadblock when developers need access to granular, low-level operating system features. B4X bypasses this limitation by allowing direct native API interop without breaking its overarching declarative model. We can observe this through the inline #Java code blocks embedded directly within the B4X script. The codebase uses a specific _pin to home method to target the native Android shortcut manager. Inside this block, an API level check ensures the SDK integer is 26 or higher, preventing exceptions on legacy Android operating systems. During the application's first launch cycle, a high-level B4X flag evaluates to true, commanding this low-level inline Java method to execute. These escape hatches allow developers to maintain the speed of a cross-platform framework while retaining the ability to call specific platform features when needed. Layout math, global routing, z-index overlays, and native interop. These discrete mechanisms form the foundation of the application. The Daisy UI wrapper serves primarily for developer velocity. It operates as the aesthetic skin. The actual structural integrity relies on the programmatic resize engine and the centralized B4X main page router. In traditional MVC setups, view logic and application state often become entangled. Here, the separation of concerns is strictly enforced in a clean two-tier hierarchy. Keeping child components entirely stateless preserves pristine life cycles and highly maintainable components over the long term. Engineers evaluating UI toolkits can look to this modular approach as a blueprint for balancing developer speed with architectural stability. Rapid development succeeds when routing state and UI assembly are decoupled, ensuring the foundation remains stable even as the visual layer evolves.